EdYoda, the end of your job search and the beginning of your dream career. EdYoda's live sessions are taught by industry experts, giving you hands-on experience and practical knowledge with real projects, not just degrees. EdYoda's industry-recognized certifications will help you stand out in the job market. And that's not all. With EdYoda's exclusive job board featuring 500+ companies, finding your dream job has never been easier. Say goodbye to endless job searching and hello to your dream career with EdYoda. Join EdYoda's student community today and start building your dream career.
Hello, hi everyone. Welcome to the workshop. I hope you all are able to hear me clearly. A quick check in the chat box, a quick hi. So I know you all are excited. Today we are going to have a workshop on machine learning. Now I know you all might have heard about this topic somewhere or the other. And today we are going to discuss about it. What is this machine learning? And a quick reminder to you all, if you haven't still clicked on the right like button, now would be the right time to do it. So quickly click on that like button and subscribe to the channel, press the bell icon so that you keep getting notified when we keep having workshops like this. And today our topic is going to be machine learning. We'll begin just in a few seconds. But before that, a little bit about EdYoda. So EdYoda is an e-learning platform where we educate you on job relevant skills and then connect you to job opportunities via our hiring partners. And this is one of our initiatives where we are trying to learn about machine learning. And if you want to learn like more detailed courses, like more in depth, then do check out our website, which is www.edyoda.com. You'll be able to find the link in the description, but don't click on the link now. Watch the full workshop and then you can check out the website after the workshop. Now we have Tanusha here with us. So first we will start with a quick simple question to all of you, which is, from where are you all watching this workshop from? I'll start first. I'm doing this live stream from Bangalore. Tanusha, where are you doing this live stream from?
I'm currently in Kolkata.
Great. So let us know where are you watching this live stream from in the chat box. I want you all to participate. So quickly let me know in the chat box. I'll be checking the chat box and replying to you all also. So quickly let me know in the chat box. Now I won't waste any more of your time. I'll hand it over to Tanusha so that we can begin our session. So over to you, Tanusha.
Thank you, Rishabh. It was really a nice introduction. So today we are going to do this workshop on machine learning. So I'm sure that a lot of you must have heard about what machine learning is and are very excited to know about careers in machine learning, right? Because it is the buzzword right now, and being a data scientist or being a machine learning engineer, that is something that everybody wants to be, right? So even when I was in college, I always wanted to be a data scientist. I wanted to learn more about machine learning, data analytics, and so on. So today we are going to do some basics about machine learning. We won't go into a lot of depth because I'm assuming that you all are beginners. So let me quickly pull up my screen. Okay, so this is how we are going to do this. So first of all, I'll be going to share a few slides with you on what machine learning is, what are the different types of machine learning, what are the few prominent algorithms which are there in machine learning, and few challenges about machine learning. Okay, and post that, what we are going to do is we are going to do some live coding on that, and I'm going to show you exactly how a lot of algorithms work. Cool. So let us get started. Brief about myself. So I have more than 3 years of experience across different companies like ZS Associates, Accenture Strategy, and Swiggy in roles like decision analyst, analytics associates, and data scientist. So now I'll just get started on your on the machine learning part. Okay. So first of all, what is machine learning, right? So machine learning, as you know, is a subset of artificial intelligence that focuses on the development of algorithms and models that enable computers to learn and make predictions or decisions without being explicitly programmed. Right, so you will be seeing machines all over you. You will be seeing things in which you don't explicitly code, but things are happening by themselves. So you know that this is machine learning that's doing this. So it enables the computers to learn and make predictions or decisions without being explicitly programmed. Okay, it leverages statistical techniques to automatically identify patterns and data-driven predictions or decisions. And it finds applications in various fields like finance, healthcare, marketing, and more. So you will be seeing data science applications in all kinds of fields. So you might have probably heard about things like image processing in medical science. You might have heard about machine learning in gaming. You might have heard things like quantitative trading and so on. So all of these things are basically applications of machine learning in different spheres of work, right? Then additionally, machine learning systems enable systems to adapt and improve their performance over time based on experience and new data.
घर वालों का भी था कि यार बैंक में जॉब करना है, गवर्नमेंट जॉब करना है, तो उसकी प्रिपरेशन के लिए मैं दिल्ली चला गया। बट वहां पे ऐसा है कि मैं रह नहीं पाया, मेरे मुझे वहाँ डेंगू हो गया, बहुत ज्यादा सीरियस कंडीशन हो गई थी मेरी। तो फिर मैं वापस आ गया वहां से। बट फिर मेरी शादी हुई उसके बाद। देन फिर क्या, फिर मुझे थोड़ी प्रॉब्लम होने लगी क्योंकि मेरी वाइफ को भी आगे पढ़ाई करनी थी, उसे भी आगे बढ़ना था, और मैं जिस जगह पे था वहां से कोई ग्रोथ या कहीं कुछ नहीं था। एक छोटा सा गांव था, वहां कोई कुछ नहीं। जब मेरी शादी हुई तो उसके बाद फिर मुझे रियलाइज हुआ कि यार यहाँ तो मैं नहीं रह सकता, मुझे बाहर निकलना ही है ताकि मेरी वाइफ भी अपना करियर आगे बना सके, क्योंकि वो देखती थी मैं कितना वहां परेशान हो जाता था। और एक तो इतनी छोटी सी जगह में कि मतलब कहाँ, घर से भी हम बाहर नहीं निकलते थे छुट्टी के दिन। तो उसी ने मेन मुझे सजेस्ट किया था कि नहीं, आपको अपना करियर स्विच करना चाहिए। कि ऐसे एक एड्योडा डिजिटल यूनिवर्सिटी है, तो वहां से ऐसे स्किल बेस्ड कोर्स होता है, और वो उसके बाद प्लेसमेंट सपोर्ट भी कराते हैं, बहुत सारी चीजें हैं। तो पहले तो मुझे यार बिलीव नहीं हुआ कि ऐसे तो बहुत सारे लोग पैसे लेते हैं, ये करते हैं, तो क्या ही उसमें क्या गारंटी है। तो उसने बताया कि नहीं नहीं, मैंने बहुत रिसर्च की है, काफी लिंक्डइन पे भी बहुत उनके एलुमनाई से बात की है, और एक तो उसके
1 second, Tanusha. We have a video running on the YouTube live.
Okay.
Just let you know once we switch it. All right. Or give us 5 seconds. All right, Tanusha, you are live on YouTube.
Okay, hi guys. Sorry for the break. There was some network issue at my end. So I'll just start from where I had stopped. So we were discussing about this slide, right? That what are the various ways in which you've seen machine learning happen, right? So for example, from the chart on the right, you can see that what has machine learning changed us to do. So for example, your ordinary system had your computer in which you could do limited number of tasks, right? Now with AI, what else can you do, right? So with AI, you can see that there is this robot who is actually studying the books and all. So you can see maybe somewhere in the near future, you'll actually see all those things happen, that you no longer have to actually read books and all. Your robots would be doing that on your behalf, and you just get selected for all the things and all. You come with flying colors and everything. So maybe that day is not very far. So you can see that the robot here, the machine learns for you, the machine predicts, and the machine also improves the performance. Okay. So, sorry. So the best example that comes to my mind right now is how many of you are using ChatGPT right now? So you can see that ChatGPT is something which is very closely resembles to this robot right here. So you can see that ChatGPT has improved a lot of our lives. So for example, even if you pass an entire text or a mail and you want the English to be done better way, you can actually go to ChatGPT and ask it that, okay, improve my English here. Or if you are stuck in some problem, you can again ask ChatGPT that, okay, tell me what is the solution to this. And ChatGPT will actually do this. And how is it doing? It is being fed huge amount of data that it is learning every day, right? And after that, it is learning, and then it improves its performance. It's predicting the answers based on things that it has learned. And yeah, that's a very basic and the most realistic example that I can come up for machine learning right now. Okay. So additionally, machine learning enables systems to adapt and improve their performance over time based on experience and new data. Right. So next, what we are going to do is, so these are the popular machine learning algorithms that we can talk about. So machine learning algorithms, this is just 5 of the most popular algorithms that I think you have more than 40-50 algorithms, right? So this is not an exhaustive list, but these are the most basic algorithms that you can actually do. So first of all, it's linear regression. What does linear regression do? It predicts a continuous output based on input features. Okay, so you give some kind of input to your model, and then it predicts a kind of output. Okay. Then you have logistic regression, which classifies data into categories using a logistic function. Okay, so what is the difference between linear and logistic regression? So for example, if you give some kind of data, say you say that I scored 98 in math, I scored 90 in computer science. Would I be getting admission in computer science engineering? Yes or no? So that yes or no is a kind of a category. So that is what logistic regression does. Okay. Then you have decision tree, sorry, which builds a tree-like model to make decisions based on feature conditions. So for example, if you guys are familiar with things like Kaggle, you'll be seeing this a lot. You'll be seeing housing price data set a lot. So what exactly does housing price data set do? You give it a few conditions, right? You say that, okay, the location is this, the number of bedrooms is this, okay, this has 3 or 4 ACs, then what is the price? Okay, if this works, yes. If this does not work, no. So it's like a kind of a tree. So in each with each passing tree, you have a question that has a yes or no answer to it. So that is what happening. Decision tree builds a tree-like model to make decisions based on feature conditions. Okay. Then we have k-means clustering. So k-means clustering is an algorithm that partitions the data into k clusters by iteratively assigning data points to the cluster with the nearest centroid and updating the centroids based on the mean of the data points. So don't need to worry much about the language here. You just need to know that k-means clustering is a machine learning algorithm. We learn later on that this is an unsupervised machine learning algorithm. So what does it do? It divides things according to categories. Suppose in your college, right, even if you were one entire batch, you might have been segregated into different batches, right? Like computer science or mechanical or say electrical, electronics, and so on. So suppose what is the main difference between supervised and unsupervised learning is, so things like linear and logistic regression, they have a label attached to them, right? But unsupervised learning algorithm has no label. You just have the entire data and you have to identify what are the characteristics of those particular data points and you have to segregate things. So for example, a real life example can be, suppose you have people who are CSE, ECE, EEE, and mechanical. So you can see that the least number of girls are in which batch. So you can identify, okay, this is mechanical. So this might be a practical example that that could distinguish that, okay, there are 4 kind of clusters in this batch. So one is mechanical, one is ECE, one is EEE, one is CS, based on some features. Okay, so that's one basic understanding. Then you have PCA, which is principal component analysis. PCA is a dimensionality reduction technique that transforms high dimensional data into lower dimensional space by finding the principal components. So this is basically a dimensionality reduction technique. Basically, suppose if you have 100 features in your data, this technique would help you identify the top 10 features. So it's something like that. So the 5 types of algorithms that we are talking about here: linear regression, logistic regression, decision trees. These are supervised learning algorithms, and k-means clustering and PCA are unsupervised learning algorithms. But there are way more algorithms that I have not mentioned here. Things like support vector machines, things like hierarchical clustering. These are things, or k nearest neighbors. I have not mentioned them here, okay, because the list is endless. So it's not like we can all talk about everything at once. But these are the most prominent algorithms. And if you learn the mathematics and statistics behind these algorithms, I'm sure you can understand other things as well. So we'll be delving deeper into the code once we finish 2-3 slides, and then we'll be discussing more on the code side. Okay. So types of machine learning and examples. Okay. So first of all, you have supervised learning. So what is supervised learning? The algorithm learns from labeled data to make predictions or classifications. So suppose, what do I mean by labeled data? So labeled data means something that I am giving the machine learning algorithm to train itself on. Suppose I say that suppose I give it give a lot of data. Okay, so for example, I've given here. Okay, so for example, you have email filtering. So using labeled examples to classify incoming emails as spam or non-spam. So this is the most common example. So you guys all might have a Gmail account, right? And you must be getting all kinds of emails. Some of the emails are necessary emails. Some of the emails are spam or promotional emails, right? So a lot of times you would get the option that you click on it and you mark it as spam. Okay. So for example, from a particular website, I mark it as spam. You'll see that next time you would normally not get any further emails from that particular website. Why? Because Gmail has learned that you have asked it to classify, you have asked it to put that particular website in the spam category. That's why no more emails you will be getting from that particular email address. Or always you will see that there are some exceptions. For example, a lot of times I have put LinkedIn emails into spam category, but then it's not that I won't get any other emails from LinkedIn, right? So in that case, it's not a poor labeling. It just means that your data is, it cannot actually segregate between spam and non-spam. But then emails like promotional emails, for example, you see things like 50% off, 40% off, free, and all these things. What it does is, there is something called natural language processing, and there you can identify some keywords, right? So wherever you see keywords like this, 40% off or free or things like that, it would identify, it would keep all that data into its database, and then it would say that, okay, wherever you find these kinds of keywords in your email, you can classify them as spam. Okay, so that is one example of supervised learning. And why is it called supervised? Because you are training the algorithm to use these as examples. So you are giving all this data to the algorithm. You're saying, okay, let me tell you that this is spam, and this is spam. So now, if a new email comes, can you predict it for me that if it is spam or non-spam? So hence, it's called a supervised learning algorithm. Understood? Next, we have unsupervised learning. So in unsupervised learning, the algorithm learns patterns and relationships in unlabeled data. So this is the example that I was giving you for the different batches. Okay, right. Suppose in the first year, you're not exactly segregated into different batches. Then how can you understand how many clusters are there? How many patterns are there? What all can you understand? So for example, I've given you one thing, which is customer segmentation. So grouping customers based on purchasing patterns, demographics, or behaviors without prior labels. Okay, so that means that your data does not have an input or an output specified explicitly. It just gives you a lot of number of columns or a lot of number of datas, right? But you don't get any kind of information that you're feeding explicitly to the model. Okay. So for example, when I was working with Swiggy, I saw a lot of cases where the customer purchasing history was given, what all behavior they explicited, and a lot of other things were given. But then you could see that these customers had some kind of segmentation in them. So the highest purchasing people were having a different category, say ultra high category or P1 category. Then the next kind of category, which made purchases but not that often, say they were a P2 category. The next category of people who made one purchase per month or were very irregular kind of customers, they are another category. So this is how you are grouping customers based on finding some particular kind of pattern. In this case, this was a purchasing pattern, or the amount of money that you're spending, or behavior, right? You can also have some demographics, right? So for example, just think you are abroad, right? You are abroad, someplace abroad, and you see that a lot of Indians are there. But suddenly you see that a lot of people are speaking in Hindi, right? So by default, you can say, okay, these guys are speaking Hindi, which means they might be from North India. Okay, that's just a thinking. It can be something else as well. Then you can see a lot of people who are speaking in Bengali. Okay, you can say, okay, these guys are from East India. So this is one way how you can identify and you can group people, but you don't have any label, right? I mean, a machine who is looking at all of them for the first time, he does not know who is what. So we can only identify what are the different categories or what are the behaviors. Okay, so this is two examples of supervised learning and unsupervised learning. The last thing is reinforcement learning. Okay, so basically the algorithm learns through interactions with an environment to maximize rewards. Okay, so how many of you do this a lot? How many of you play a lot of games and everything? So this is the perfect example of reinforcement learning. So reinforcement learning has been successfully applied to teach AI agents to play games such as chess, Go, and video games. So have you ever wondered how this thing happens, right? Because the only games that I have played honestly are chess and Ludo. So these are two exactly diverse spectrum of games. But then if you see, whenever you play chess, you'll always see that there are different levels, right? Level 1, level 2, level 3. And you will find that it is always easier to beat an AI robot who is playing in level 1 than an AI robot who is playing in level 10. How do you think this is happening? This is happening because the bot, it learns the moves, right? So for a level 1 player, it learns what a typical moves the level 1 player does, and it is learning it, and it is applying it in order to play with a completely new person. And then a level 10 person is again having another set of data which it is reading and trying to reproduce. That's why the AI of level 10 is also equivalent to a person of level 10. So that is some kind of analogy that you might have done. So that is about chess. There are way more games. Whenever you see there is a game in which no person is playing against you, but an AI is playing against you, or a robot is playing against you. You know that is happening because of reinforcement learning. Okay, so you can see machine learning and its applications, practical examples everywhere around you. You can see. So that's why you know that this field is very, very lucrative and everybody wants to get into it. Okay. So now that we have learned about the types of machine learning and the examples, so I'll be giving you some practical exposure of all these codes. We'll be studying about customer segmentation. We'll be doing the actual coding for this, and even for email filtering. However, some concepts you might find slightly more difficult than others because it's not just one line of code. You have to do a lot of different things. A lot of different steps have to be followed. So even if you don't understand, it's completely okay. You just need to understand what all is happening in the steps, right? So next, we have what are the key steps in machine learning. Okay. So first of all, you have data collection. So gather relevant data for the problem at hand. Then you have data pre-processing. Clean and prepare the data for analysis. Okay, so before this workshop, I had also done one workshop completely on EDA, which is exploratory data analysis. So that in that, the first two steps which you can find, data collection and data pre-processing, they are the first parts of EDA. And even before even thinking about doing any kind of machine learning, you need to do your EDA well. So let us see what EDA is. So first of all, you have data collection, where you're getting data from a lot of resources. Okay, so you can get your data from surveys, you can get your data from an interview, you can get your data from various online repositories, you can get your data from call recordings, and various other sources you can get your data from. So that is data collection. Okay, then you have data pre-processing. What is data pre-processing? You have to clean your data, you have to get rid of it from missing values, you have to remove outliers, you have to try to find out that all the features are relevant or not, and you have to prepare the data for analysis. So next we have feature engineering. So what is feature engineering? You select and transform the relevant features. So suppose you have a data with 100 columns, you know that necessarily not all 100 columns might actually be useful, because the more and more columns you use, the more and more data you use, the more memory your algorithm has to spend, right? So that's why you have to optimize things, and that's exactly what feature engineering does. After that, it's model selection. Choose an appropriate algorithm or model. So you know that there is no one size that fits all concept in machine learning. So for example, a problem that can be solved using a support vector machine can also be solved using linear regression, right? You just need to understand which is more accurate, which is more precise, which takes lesser time to run, and proportionality to that, the less memory is being spent, right? Because all of these are not only taking time, they take a lot of cost as well whenever you are running something on the warehouse. Okay, so you need to think about that as well. Then you have model training. So train the model using the label data. So again, this depends. If this is a supervised learning model, then model training is important. Otherwise, model training is not important. Then you have model evaluation. Assess the model's performance and make improvements if needed. So what do we mean by model evaluation? So you give a model, you say this algorithm is suitable for this kind of problem, and then you train the data. So your job is not over yet. You need to understand, you need to identify that if the model that you are specifying, is it accurate enough? Because ultimately, what is your end goal? Your end goal is to predict the things well. So if your data does not work well in the training part itself, how can you expect it to work well in the test part? So again, what is training and test? So you have a huge data set, right? You have to break it into training and test. So training is the part of the data that you use the machine to learn. So whenever you feed that kind of data to the machine will learn all these features. It will say, for example, this person, the same example I'd give, mathematics 98, computer science 90. Okay, the person is admitted. So these are, suppose like this, I have 10,000 more rows that the machine has to learn. So for now, if I suddenly give, okay, this is the new data, you have 90 in maths and 90 in computer science. What are the chances that I would get admitted? So that is a new data. So that is called test. Okay. So model training, you have to train the model using the label data. Model evaluation, you have to assess the model's performance and make improvements if needed. So you have to study a lot of parameters like accuracy, precision, recall, F1 score, and all these things. These are some things that we'll cover in the later slides. And after that, if you see that your model's performance is good and the prediction is also accurate, you can deploy the model into production. So deploy the trained model for predictions or decision making. So that is the end step. So you have about 7 steps, which are not only key steps in machine learning, but key steps in any data science project. Okay. Okay. Before going into all that, we should be doing some practical coding right now. Okay. So just give me a minute. Yeah. So what we are going to do is we are going to learn a little bit in detail about each of the algorithms that I had mentioned in the slide, and then we'll be doing some basic level code. Okay. Towards the later end, what we'll be doing is we'll be actually doing the customer segmentation problem as well as try to do the spam filtering problem. So they might be slightly complex at this point of time, but don't worry about it. Everything is just syntax. So as long as you're understanding the math behind it, you know that you are going in the right way. Okay. So what is linear regression? So you know that linear regression is a supervised learning algorithm, which means that you are giving the model enough data to learn, and then you're again asking it to perform on an unlabeled data set. So you're asking it to perform on a new data set. So that's what supervised learning is all about. Now let us know what is linear regression. So linear regression is a statistical modeling technique. So linear regression is a statistical modeling technique used to understand and analyze the relationship between a dependent variable and one or more independent variables. It assumes a linear relationship between the variables where the dependent variable can be predicted as a linear combination of the independent variables. Okay. The basic logic of linear regressions involves fitting a line to the data points that minimizes the overall distance between the line and the data points. The line is represented by the equation y is equal to b0 plus b1x1 plus b2x2 and so on. So that's the math. You must have heard about the y is equal to mx plus c line, right? That's the equation of a straight line. So what does linear regression model do? It tries to get the best fit line or the best fit straight line from the data which is given. Let me give you an example. I'll try to show you this on Paint. So for example, this is a data that you have, and suppose you have all these data points. Suppose you have this, your data is this. So just by looking at it, what would if you run a linear regression model on this, it would try to analyze that what should be the best fit line. So you will see this is a kind of line that your machine learning algorithm would do. Now, how exactly is it doing that? How exactly are you getting to that maths? So it would actually calculate the mean square distance of each point from this point, for example. So you can see this is one length that it would continue. This is, since this is on the straight line, it would be 0, then this is again 0, and then this. So from this, we can understand that if I run a linear regression model and this is the best fit line, you have to minimize the distance. Like suppose in place of this line, if I had suppose done this, for example, you know, you are almost calculating double distances, right? You're calculating all these distances. So, you know, this is not the best fit line. So this is what your linear regression. I hope this visualization was slightly helpful for you guys. So this is the logic of linear regression. You have to get the best fit line that minimizes the overall distance between the line and the data points. Okay. And the line is represented by the equation y is equal to b0 plus b1 x1 plus b2 x2 and so on. So you just need to remember y is equal to mx plus c. Okay. Where y is the dependent variable, x1, x2, xn are the independent variables, b0 is the intercept term, and b1, b2, bn are the coefficient or slopes associated with each independent variable. So the math behind linear regression involves estimating the values of the coefficients b0, b1 till bn using a method called ordinary least squares. That's what we were doing, right? We were trying to find the differences and then trying to do a square of it. OLS aims to minimize the sum of the square differences between the predicted values of y obtained from the equation and the actual observed values. So that's what you're trying to do. You're trying to get the overall distance between the line and data points. You're doing a squared calculation of it, which is called ordinary least squares. Sorry. So let me give you an example of the code that we are going to do today. So first of all, I'll be importing NumPy because I'm going to use a NumPy array, right? In order to give you the input array and the output array, I'll be using a NumPy array. I hope you guys know what NumPy is. NumPy is standing for numerical Python. Okay, so it's like an array that you have, just like in Python, you have 1D, 2D arrays. So that's very similar to that. Okay, so I hope you know what matplotlib is. So matplotlib is again another data visualization library where you can plot the graphs and look at your variables. Okay, then I'm importing the linear regression module from sklearn library. Okay, so sklearn stands for scikit-learn, scientific Python. So basically, you get all your machine learning algorithms and your libraries from this module. Okay, so suppose I have a sample data set. Sample. Say x is numpy.array 1, 2, 2, 4, 3, 6 and 4, 8. 3, 6 and 4, 8. If you look at this carefully, I'm trying to find some kind of a pattern. So you'll see each of the second element is exactly double of the first one. So I'm actually giving it some hint that you can make your model this way. So this is our input variable. Okay, this is the input or the independent variable. Let me put it as independent. And this is your dependent or output variable. So, okay, so you can visualize it this way that, for example, you have A, you have B, and you have your output. Okay, so you have 1, 2, and the output for this is 2. Then you have 2, 4, and the output for this is 4. So this is how you should be visualizing this. So this is a table basically, okay, where these are the independent variables and this is the dependent or the output variable. Okay, so now what we're going to do is we are going to fit this model. Okay, so what do we mean by fit? We are going to train the module on it, right? So I'm going to create an instance of the linear regression model. So how do I do that? Linear regression. Okay, now I do model.fit. So what is model.fit? Basically means that I'm trying to fit the data, according to whatever data I'm giving, I'm trying to make the machine understand that, okay, read this and try to understand this. Okay, so that's a basic understanding of what I'm trying to do here. So you're giving the input array and you're giving the output array, and you're asking the machine that learn it. So now when you're predicting this, for example, let me predict it on the same data first, and after that I'll predict it on other data. Okay, suppose you do this. Oh, sorry, I made some spelling mistake. So you can see that when I'm running things on the same data, the machine has learned by itself, right? Because you can see that it's giving me 2468. What am I trying to do here in model.predict? In model.predict, I'm giving it the explicit data, right? I'm giving it the same data here again, this array 1, 2, 2, 4, 3, 6, and 4, 8. And when I'm trying to get the prediction, this is what I'm getting 2468, which is exactly same as what this is. Now you guys can give me some example on what I can test this on, for example. So you can say x test is equal to, say I'm not using this exactly. Let me use something else. Instead of 1, 2, let me remove 1, 2. I'll maybe start from 2, 4 and 5, 10. Okay. So now in place of x, I'll make it x10. So you can see that the model has learned. So I have not told him, right? Because this data point 5, 10, this is completely new data. I have not told the linear regression model that, see, you have to reproduce the second item. So if you see 10 on the second data, you have to write 10. It has learned by itself. Okay. So that's why you can see the output over here. The prediction is absolutely accurate. It is 4 and 10. Right? So this is what linear regression is all about. It tries to learn the points and then it tries to reproduce it. This is true of every algorithm, every supervised learning algorithm. But let me give you a visualization of this so that you can understand. So I'll take a minute because we'll probably have to write a lot of visualization code. So just give me a moment. This would be a little long code. So plt.scatter. So what am I doing here? I'm doing here is I'm making a scatter plot. Scatter plot means you will be putting everything a point at a time. Okay, and this is the actual plot. So you can see I'm using X here, right? So now, for example, I use in place of X, I use X test, for example. And 0 y, say I use a red color here, label is predicted. Okay, so now I'm going to plot this line. Plt dot plot y predicted, color is equal to green, and label is regression line. So now I'm going to set the parameters like plt.xLabel. So this is, although this is optional, but this gives you a good visualization impression that what is independent variable, what is dependent variable. Dependent variable. Plt dot title is linear regression, plt.legend, plt.show. Okay, so let us see what we get from here. Getting an error. Okay, must be the same size. So I have only selected 2 elements here, so I'll have to make it slightly longer. Maybe I can select the last 2 items from here. Okay, yes, that should do. Yeah, so you can see this is the best fit line which you are getting. Okay, so you can also find a straight line. So this is your actual, right? Your actual was everything was in a straight line. So for example, in place of y predicted, suppose I had given just y, you would have got a straight line, right? I have only given values which won't exactly follow a straight line, but now you can see that the red values over here, they are the predicted values, right? They're the predicted values, and the blue values over here are the actual values, and they all fall in a straight line. And your linear regression model always tries to put everything in a straight line and find the best fit straight line. So you can see this is the best fit straight line because 4 of the points lie in the same plane, and there are just 2 points which are far away. But even then, this would be the best fit line. You're never saying that you have to include all the points in any way, right? So this is about this is linear regression model. Okay, this can be used to do any kind of supervised learning problem. However, that's the case. Any kind of supervised learning problem can be done with any algorithm. You always need to check what is the accuracy, precision, and all those things. Okay, but this is the first algorithm that every beginner learns when he or she is doing machine learning. So I hope you understand this part pretty well. Okay, so in this example, the independent variable x. So remember this, that your input variable is always independent. Why is it independent? Because it's not dependent on any other column. Okay, it's independent by itself. The independent variable x is a 2-dimensional array, and the dependent variable y is a 1-dimensional array. The y will always be a 1-dimensional array because it's the output. The linear regression class from scikit-learn is used to create a linear regression model. The fit method is then called to fit the model to the data, and the predict method is used to predict the dependent variable. Finally, the coefficients and the intercept of the fitted line are printed. Okay. So if this is clear, we'll move on to logistic regression. Okay. So logistic regression, what is logistic regression? One basic example I'd given you. So that's the difference between linear and logistic regression. So in linear regression, you'll get the points explicitly, right? But in logistic regression, you'll have categories instead of points. Okay. So what is logistic regression? Logistic regression is a statistical modeling technique used for binary classification problems. It predicts the probability of an event occurring by modeling the relationship between a dependent variable and one or more independent variables. Unlike linear regression, logistic regression predicts a binary outcome rather than a continuous one. The logic of logistic regression involves fitting a logistic function, also called the sigmoid function, to the data points. The logistic function maps in a real valued number to a value between 0 and 1, which represents the probability of the event occurring. And I hope you are aware of this thing. This is called a probability. This is called a sigmoid function. Even if you're not understanding what this is like 1 by 1 plus e to the power minus x, right? And this would always give a value which ranges from 0 to 1. Okay, means either 0 or 1. Okay, so that is about your logistic regression, where p is the probability, z is the linear combination of the independent variables and their coefficients. In logistic regression, we use a method called maximum likelihood estimation to estimate the coefficient that best fits the data. Okay. The math behind logistic regression involves using optimization algorithms such as gradient descent to minimize the cost function, which is based on the likelihood function. Okay, enough of theory. Let us do some code, right? So this is slightly a big code. Let me. Okay, so I'll give you that example only, the math and computer science example that I was giving you. So I'll just give some sample data, 4 or 5 sample data sets. NumPy.array. So although I'm using NumPy here, you guys can use pandas or scikit-learn datasets as well. Okay, so there's no limitation on that. So suppose you have 37. I'm just picking up some random points. Okay, 37 and 75, for example. Then you have 45 and 85. And then you have 78 and 69. Then you have 56, 73, 89, 87, and 76, 73. Okay, suppose you have these values as your input or independent variables. And for the y part or the output part, suppose you have this as your value. Sorry about the noise, guys. It's I'm having some construction work here. So you have 0, then you have 0. I have 1, 2, 3, 4, 5, 6. Okay. You have 1. Let us make it 79 in place of 69. Let's not confuse the algorithm much. Okay. Then we have 0. Then we have 1. And then we have 1. So what exactly is the 0, 1 representing? 0 means the person has not been admitted. And 1 means the person has been admitted. Okay, simple. So you have 2 scores. 37, 75 means that the person has scored 37 and something, 75 and something. So he's not admitted. Vice versa for 45, 85 and so on. Towards the later ends, you can see that the numbers and all, they have increased. So you can say that if a person gets this type of score, he or she would be admitted. Okay, so this is the sample input and output data. Okay, now I'm going to create a model which was similar to logistic regression. Okay, so before that, I'll have to run this line again. Just in case of linear regression, I'll have to write logistic regression. Okay, so model is equal to logistic regression. And we are doing the same thing again, model.fit x and y. Now I'm going to give some new data points for prediction in place of using the same old points, new points. Okay, say let me make some new value. So new data np.array say 67, 72, 55, 90 and 80, 85. Okay, so now let me see how well is my data working. So new data predicted. So predicted probability. So model dot predict probability of new data Okay, so let me check what is the probability that I'm getting. Okay, so I'm getting some number which it's coming definitely in the sigmoid function. So you can see that there are some values which are like 0.63, which is closer to 1 than it is closer to 0. Then again, you can see there are some values which are closer to 0 rather than closer to 1. Although I don't think 5590 should be this less. Probably the logistic regression model is still working on it, and we have given very few data points for it to learn. Maybe if we give more and more data points, it would be able to learn better. But this is an accurate representation. So if a person gets 80 and 85, the probability of admission is 0.9985. Why? Because it's trying to mirror this one. It's trying to understand that, okay, this is very similar to this. So that's why if this is equal to 1, so this should definitely be equal to something very near to 1. Okay, and this kind of data it's not finding anywhere. That's why it's giving us slightly erroneous data. So when you actually look at the accuracy of this model, you will see that it will not get a very high accuracy model, because this is not exactly 0.02. So how can you counter this? So this is again some challenges of machine learning, which is called underfitting. Okay, so what happens when you are underfitting? So you have given very less data, and the logistic regression model was slightly unable to understand that what you're trying to get out of it. Okay. So that is about logistic regression. Let me give you a visualization of the same, just like I had done for linear regression. This would be slightly bigger code. Let me try doing this towards the end again, or do you want me to do it now? I'll just write the code quickly. It's just a lot of data visualization code, pipeplot and all that. So let me just do it very quickly so that you can visualize logistic regression well. I'll explain you line by line whatever I'm doing here. So don't worry about that if you're not understanding. So let me explain you what I'm trying to do here. So what are we trying to do is we are trying to get a visualization, right? So since we're trying to get a visualization, I'll just keep myself on mute unless this construction sound is coming, okay? Once I'm writing the code, I'll come back and I'll explain you whatever I'm doing. Okay, so this is a basic representation of what we are trying to do using logistic regression. So you can see that all these new datas which are here, they are plotted using the star, and all the old data was plotted here. So you can say these kinds of data, for example, things that you can see like say this one, 85 and 86, right? 85 and 87, this data. You can see this is on the right side. And again, you can see this one, 83 and 80, right? Probably this one, 89 and 87. So all of these are marked as 1. So you can say that whatever values that you can see towards the right end, which are towards the right of this blue marker over here, they are all things which are more favorable to get a admit, right? So all these values which you can see over here, these 3 points, so you definitely know they are all 1. So this is 1, this point is 1, this is 1, and this is 1. So these are the 3 dots that you can see. The star that you can see here is because of this value, 80,85. And if you remember the value that we were getting, that's also 0.99 something. So you know that's more probable to get an admit. This star over here, which is in the bottom, that is slightly in the middle of it. That is, you can remember the probability that we were getting was something around 0.6 or something. So it's not very sure that the person would get an admit or not, but this is still slightly on the admittability side. But here you can see these 3 values are on the 0, that they did not get an admit. And again, this value, which is like 55,90, this is also coming towards the left side. So you know this clear demarcation has been done using logistic regression, and that is how you can visualize it in a better way, right? So this was about the different kinds of regression models, linear and logistic. So what are we doing here? Okay, so what am I doing here is, so x of 0 means that I'm looking at this particular values, 37, 45, 78, 56, 89, and I'm selecting the min out of it. And then this one, I'm selecting the max out of it. And y min and y max are these values, 75, 85, 79, and so on. And I'm selecting the max and min values out of it. So ultimately, I'm creating a grid. Okay, I'm creating a grid that whatever values are above this grid would be getting an admit or a 1 value, and whatever values are below this grid would be getting a 0 value or a not admitted value. Okay, so this is what we are calling as grid points. Okay, and then we are doing all these calculations, and these points all over here, pyplot.contour or pyplot.scatter, these are all your matplot-like functions, right, which are giving you various parameters. So right here you can see things like color is equal to gold. So color is equal to gold just means that you want this to be colored in gold. Then you have edge color is equal to black, label as training data, new data, and so on. And these are basically whatever labels that you use for x and y axis and so on. Okay, so this was about linear and logistic regression. Now we are going to do 2 things in once. One is we are going to learn what is a decision tree all about. And next we are also going to understand what are the different steps in machine learning. So if you remember the slide that I was showing, you have 7 steps in machine learning, right? So we are going to understand all those steps with the help of a decision tree classifier. Okay, so first of all, what is a decision tree? A decision tree is a supervised machine learning algorithm used for both classification and regression tasks. It creates a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. Okay, and the logic behind all the decision trees lies in the partitioning the data set, right, on feature values to create a homogeneous data set, to create a homogeneous subset that maximize the information gain or minimize the impurity at each step. So this algorithm leaves a hierarchical if-else questions that leads to a prediction. And mathematically, decision trees aim to find the best split at each node of the tree by evaluating different splitting criteria. Okay, things like entropy or classification tasks. So don't worry about that. Just think of it as a flowchart kind of an arrangement. Okay, for example, you want to see that, okay, should I buy this house? Yes or no? If this feature is there, so if it's more than 1200 square feet, then yes. Else, no. Now, when you have answered yes, so you don't answer yes completely, you answer maybe. Then again, if you say if the number of rooms is less than 2, then you say no. Else, again, maybe. So you put a series of different cases and different if else conditions, right, before you actually make that decision. So that is why it is called decision tree. Okay. So let us, along with doing this task, let us try to understand what are the different steps in machine learning. So the first step is data collection. So now you're going to learn one more thing about sklearn, scikit-learn, which is not only importing the linear models like linear regression and logistic regression. We're also going to utilize the datasets module of sklearn, which would help us to gain datasets and collect data, right? So sklearn.datasets import load iris. So iris is basically a data set which consists of different information like the kind of flower, kind of iris, using the petal width and all those examples. So some of you might be knowing what an iris data set. It's a very popular data set. So what do? You do data is equal to load iris. Okay. Now, suppose if you run this right now, you can see this is the data. Okay, this is like a NumPy array again. Okay, and this contains of a lot of data, petal length and all these things you can see there. Suppose you now create the x-axis and y-axis. So x is data dot data and y-axis is data dot target. So since this is a load iris, and since you're getting this exactly from scikit-learn would only tell you what is the data and what is the target variable that you're doing. So that's the advantage of importing your data set directly from scikit-learn. Okay, you don't need to actually specify what is the x-axis, what is the y-axis and so on. Okay, so once this is done, next you have data processing. Clean and prepare the data for analysis. So what are we going to do here? We are going to do sklearn dot pre-processing import standard scalar. So guys, although this is one way of pre-processing the data, don't do this as a direct step. When you're just doing a normal data analytics problem, you have to go through all the steps which are there and not just directly do the scaling part. So scaling part is just before you do machine learning. But since we know that the IS dataset is something which is already pre-processed well and all, you can directly start from the pre-processing step. Okay, so what are we trying to do using this part? Okay, so what is data pre-processing and what exactly is standard scalar doing? So this is an example that I even given my normal classes. So for example, you have different columns, right? Forget iris dataset. Suppose you have different columns. One is, say, the height of people. It ranges from, say, 150 centimeter to 300 centimeter, just hypothetical. Then again, you have a weight of people, which ranges from 50 kg to 100 kg. And again, some other thing which ranges from a completely different scale. So your machine learning model does not really understand that all these things are different. It tries to make everything a homogeneous unit. So it wants everything to be, say, scaled into 0 to 1 or some other range, right? 1 to 1, minus 1 to 1 or 0 to 1. So that is where your standard scalar comes into place. So it is necessary that every column in your data is scaled to the same value. It's not like one value has a range of 50 to 100, one thing has a range of 150 to 200. So everything is different, right? You have to uniform everything. So that uniformity is brought about by your standard scalar. So the different kinds of scalars are there. A standard scalar, min-max scalar, different kinds of scaling is possible using the import process from sklearn.preprocessing, but this is one way. So what you're going to do, you're doing scalar.fit transform to x, where x is your input. Okay, so this process is done. Next, you do feature engineering. where you are selecting and transforming the relevant features. So instead of keeping 100 columns, you're selecting the 10 best columns. That's an example. So, and if you see from here, everything is, you're not even writing 1 or 2 lines of code. You're doing everything using pre-processed modules which are already there, right? So here also I'll be importing sklearn.feature selection. Import select k-best and then sklearn.feature selection, import f_classif. So let me explain you what exactly is select k-best and f_classif. Okay. So yeah. So what is happening in select k-best? So you are selecting k-best features. So out of 100 features, you are selecting 10 features. So you will be at a later stage, you will be saying k is equal to 10, for example. So you have to select what are the best few features. And f_classif is the way how you are identifying it. How are you, and on what basis are you calculating the best features? So these are the two modules that you're importing from sklearn.feature selection. Then we are using a selector module. Selector is equal to select k best score function is equal to f_classif and k is equal to 2, which means I'm selecting the best 2 features. Okay. So in this case, we don't even have 100 columns, right? So why do we need to select 10 columns? We have very limited columns. That's why we are selecting the best 2 features out of here. Sorry. Okay, so this part is done. So now I've changed the x-axis or the input variables to just the 2 features, which are the best 2 features. Select k best. Okay, and after that, what we are going to do? We are going to do model selection. So these are the steps, right? You just have to go along with that. First step is data collection. Next step is data pre-processing, that you do the standard scaling or min-max scaling or whatever scaling there. Then you do the feature engineering. That is, you are not selecting all the input columns or all the input features. You're selecting the best features out of that. Next is, after you have done that, you are doing a model selection. In this case, we are not doing any selection. We are directly using decision tree classifier. And hence, that's what we are going to do. So from sklearn, .tree import decision tree classifier. Okay. So in this case, you can see a difference. It's not sklearn.linear model anymore, because tree is not a linear model. It's a different data structure of its own, right? So even if you have done data structures in when you're doing software development training or something, you would have known that BST, DST, and all these things are there. So yep. So okay, model is equal to decision tree classifier. And then this part is done. Okay, so we have done the model selection. Now we have model training. That is, we are training the model using the label data. So what is our new data? We have X selected here, right? That would be our data. And we have to select it and we have to train it with the Y over here. That is data.target. So let us do that. Let us do the model training. So we just have to do model.fit X of selected and Y. Done. Now we have to do the model evaluation. We have to assess the model's performance and make improvements if needed. So now we are going to learn something new, which is called getting a cross-validation score from sklearn. So there are different ways of evaluating model performance. One way is the cross-validation. One way is actually getting accuracy, precision, and all that. So we'll do all of that. So sklearn.model selection import cross val score. Scores is equal to cross val score of model X selected and Y, and CV is equal to 5. Okay, so what is CV? CV means cross validation. I'm doing 5 sets of cross validation. Okay, so this, what is happening is I'm doing the same process again and again, and I'm doing multiple folds of this, and then I'm trying to identify how is my model performing. So why are we exactly doing this? Cross validation is a very important step that helps you facing problems like overfitting, underfitting, hyperparameter tuning, and so on. So this is a must step. Even if you're doing accuracy or precision at a later stage, what happens is this evaluates your model with different data that you're collecting at different points of time, and then it's trying to identify how is the model's performance. Okay, so this is an important step. And then let me do mean accuracy. Is equal to scores.mean. Okay, and after that, let me also print this just to see how much is the accuracy. And lastly, you have the model deployment, that you're deploying the trained model for predictions or decision making. So that part we'll do later. So you can see that the mean accuracy is 95%, right? So after you've done this cross validation step, you're seeing that your score accuracy is 95%. So you can say that decision tree is a good model for this particular data, right? So you can, as I was saying, you can use all the different kinds of supervised learning models as well. There is no one size that fits all. And then you can actually check what is the accuracy score. So once you see that the accuracy score is high enough, you can actually deploy it. Okay, so once that we have checked what is the accuracy, now let us test it against some new data. Before going to new data, let us check what X scaled represents. So this represents these entire types of data. That's why we are choosing 4 terms over here. So you have -9 to the power -1, which is -0.9, 1.01. So this is the result of standard scaling. So after you have done scaling, this is the result. And what is the Y value? Let us check that also. So Y is 0, 1, or 2. Okay. So these are the types of predictions that you're getting: 0, 1, 2. So this is very similar to the logistic regression problem that you had there. You had a list of combinations of independent variables and you're getting a dependent variable as your output. So now here also we have 4 values. Now let us see what the output is if we are getting 0, 1, or 2. So getting new data scaled is equal to scalar dot transform new data of selected is equal to selector dot transform new data scaled. And lastly, you have prediction is equal to model dot predict new data selected. Okay, now you see what is the prediction. So you see that you get a value of 1. So you have to get something from 0, 1, 2, right? So you're getting something of 1. Now, we don't really have any way of verifying that because there are a lot of rows over there. But since we know that the accuracy was 95%, we can assume that the prediction would also be similar in that way. So what are the various steps that you need to do? So first of all, you need to do data collection. Okay, you can either get your data from NumPy, you can get it from Pandas, you can get it from Seaborn, you can import it from your sklearn.datasets. The advantage of getting a data set from sklearn.datasets is you don't need to define your input variable or output variable. That is definitely given, right? Then you have data pre-processing. So here, this is an important step because of the reason I said you have to scale everything into one standard scale, because you can't have one parameter that is measured using millimeter, one thing is measuring centimeter, one thing is measuring inch. So that's the basic understanding that why everything should be uniform. Then you have feature selection, feature engineering, in which you don't really use all the features. You only use the top something feature. In this case, we had used 2 features because we don't have that much features to select. Then we have the model selection. In this case, we had thought from the beginning only that we are doing decision tree. Then we are doing model training. Model training is nothing. You just need to do model.fit. Next, we are checking the model's performance and making improvements if needed. In this case, we are doing the cross-validation step, which is an important step. Post that, we are doing the model deployment and we are checking how is our model performing on new data. Right? So these are the steps for any algorithm that you take up, any supervised learning algorithm that you take up. But yeah, decision tree is something that works this way. So we are done with the supervised learning algorithms. Let me give you a brief understanding of what k-means clustering is. It might be possible that we are not able to do all the things today because the time is running off. So what I'm going to do is maybe today we won't be able to complete the spam ham classifier, which is not required because that involves a little complicated understanding of natural language processing and all. So what we can do is we can solve the customer segmentation problem using k-means clustering. Okay. So what did we learn about unsupervised learning so far? So we learned that what is unsupervised learning? Unsupervised learning basically means that the model does not learn or the model does not train from any pre-classified or pre-labeled data. It learns on the basis of the data which is or the data or the patterns that it can get from the underlying data, right? So what is it? So k-means clustering is an unsupervised machine learning algorithm used to partition a data set into k distinct clusters. The algorithm aims to minimize the within cluster sum of squares, also known as inertia, by iteratively assigning data points to the nearest cluster centroid and updating the centroids. So the logic behind k-means clustering algorithm is as follows. Initialization: randomly select k data points as initial cluster centroids. Assignment: assign each data point to the nearest centroid based on the Euclidean distance. Recalculate the centroids by taking the mean of all the data points assigned to each cluster and repeat steps 2 and 3 until convergence. Mathematically, the k-means clusters algorithm minimizes the objective function called within cluster sum of squares, which is like distance between the point and the centroid. So before going into all that, let me again open up Paint. Let me show you that k-means clustering is not as difficult as the theory looks like. Suppose you have all these data, right? You have 1, 2, 3, 4, 5, for example. Things like this. Then you have 1, 2, 3, 4, 5. Then you have 1, 2, 3, 4, 5. So just by looking at this, you can say that this is one cluster, this is one cluster, and this is one cluster. Okay. And how do you identify the cluster? You just keep one centroid, which is a point which is exactly in the middle of the circle, and then you get the distance between all this. And then you recalculate it, and then you erase this cluster, and then you again find a new cluster. So ultimately, you have to find the minimum number of clusters. Okay, minimum but optimum number of clusters. Okay, so what we are going to do is we are going to identify a customer segmentation problem using k-means clustering. So okay. So what is the problem that we are trying to solve? So we are trying to find out how many customer segmentations can we do. Okay, so we are using one Kaggle dataset for this. Let me tell you. So first of all, let us import all the necessary functions. Import pandas as PD. In this case, we need pandas because we are using one dataset from Kaggle, which is a CSV dataset. So whenever we have a CSV dataset, we need to import that from pandas. Then NumPy is already imported. We need Matplotlib, which is already imported. Standard scaler is imported. K-means clustering we have to import. From sklearn.cluster, import K-means. And then you have, so what is K-means? K-means is the clustering or the unsupervised machine learning algorithm that we are going to use in this problem in order to solve a customer segmentation. So are you understanding that this problem is very different from the other problems we have seen so far? In other problems, you already have a set data set in which we have specifically said this is the input variable and this is the output variable. That is not happening in unsupervised learning algorithm. Okay, now unsupervised learning algorithm, you have to identify the x-axis and y-axis, or the x and the y variables from the patterns itself. Okay. So next, what we are going to do, we are going to use another function, which I'm telling you later why we are using. sklearn.impute import simple imputer. Okay. So this is one data set that I'm going to load. Data is equal to pd.read csv cc general dot csv. Okay, let me show you what the data looks like. So data looks like something like this. So basically this is a credit card based on credit card history, or what are the purchases that you make on your credit card. With that, you are getting segmented that if you are, say, something like a P1 customer or a P2 customer, and what kind of customer you are. Okay, so this is the data. So you can see that there is no output variable. There's nothing that we are trying to predict. What is the end objective over here? The end objective is to classify the different customers into different categories. Okay, so that is the purpose of this unsupervised learning. Okay, so again, we would pre-process the data. So what are we doing to pre-process the data? We are selecting only the numerical values. Okay, and why are we selecting the numerical values only? Because a machine learning data cannot work on text. It can only work on numerical data. People might say natural language processing is different, but that is an altogether different ball game. So now we are only looking at numerical data, and K-means clustering and all these algorithms, they only work on numerical data. So what are we going to do? We are going to extract only the numerical data. So basically everything over here is numerical except for the first ID, which is the customer ID. So we don't need customer ID in any case, because customer ID is a unique item. So we cannot identify any patterns looking at customer ID. So we don't need customer ID. We need all the other columns apart from customer ID. So how are we going to get that? Data.iloc. I hope you understand what iloc function is. It's the index-based indexing that you're doing. That you're just you're not using the first column. So this means that I'm selecting all the rows and everything from the first column onwards. Dot values. And we are done with this step. Next, what is going to happen? We are going to handle the missing values. As you know, your machine learning algorithm does not work with missing values. Here you can just look at it and you can see that there are some NaN values over here. If you see, there is an NaN value in the minimum payment part here. So before even running an algorithm, you have to deal the missing values. How are we going to do this? This is where you would be using this function, which is the simple imputer function. So wherever we are going to do a simple logic, wherever we find an NaN, we are going to replace it with mean. Sorry. So what are we going to do? Imputer is equal to simple imputer. Sorry, I used simple imputer strategy is equal to mean, which basically means whatever NaN values I have, I'm replacing that with the mean of the remaining values in that particular column. So x imputed is equal to imputer dot fit transform of x. So which basically means now there are no missing values. Okay, once I've handled the missing values, the remaining steps, some of the remaining steps are similar to the ones that you do in supervised learning as well. That is standardizing of the feature. What do you do for standardizing of feature? This is exactly same as what we were doing here. So I'll just copy this part. You just need to do a standard scalar for the same reason. So scalar is equal to standard scalar, x scaled is scalar dot fit transform of x imputed. Okay. Now this part is new. So here what you need to do in k-means clustering is you first have to determine how many clusters are needed. Just by default you have to determine. So it's a good idea to keep the default value as 10. Okay, 10 because it's not very large and it's also not very small. Okay, and once you get the 10 clusters, you have to run a function, and after that you will be using the elbow method. Okay, and you will be seeing the graph for elbow method, and once I show you the graph, you will only tell me what is the optimal number of clusters. So let us dive right into it, how to determine the optimum number of clusters which are required, because that is the ultimate end goal of your k-means clustering. So this is a empty list. WCSS basically stands for your within cluster sum of squares. If you remember, this is the thing that we are talking about, WCSS, and you had to minimize the objective function called within cluster sum of squares, right? So now what I'm going to do is I'm going to run a for loop from 1 to 10, and then I'm going to identify what are the minimum number of clusters which are required. So from I in range 1 to 11, k means, so n of clusters is equal to I, because I would run from 1 to 10, and random state is 42. There's no exact reason for which we use 42 here, but you need to specify random state so that when you run this code again, the value does not change, right? So if you can also use random state is equal to 4, but you have to make sure that random state is always equal to the same thing, right? Now you have k means dot fit of x of scaled, and WCSS dot append k means dot inertia. So this is what inertia is all about. If you see, algorithm aims to minimize the within cluster sum of squares, also known as inertia. Okay. So now what happens is, let me keep it till here, and now we'll plot the elbow curve. Okay. So what should we do? Since this is a plot, I'll do plt dot plot range of 1 to 11, which means I'll plot all 10 points and I'll get you the WCSS or the inertia numbers. Okay, and plt dot title is elbow method number of clusters, and plt dot WCSS, sorry, y label is WCSS, plt dot show. Okay. Now if I look at it, you'll be finding a kind of a graph. Yeah. So if you look at this, what can you see? Where can you find the elbow? So this is like something where I have by default defined that there would be 10 clusters, right? That's why I'm running things from 1 to 11. So you have 10 clusters. This is a random number, and then you're fitting it according to the k-means rule. And then you're appending this thing, which is the inertia value. And now that you're doing this, you can look at the data and you can see this looks almost like an elbow. So wherever you find that tip of the elbow, that would be your minimum number of clusters. So here, if you look at this, you can see that the value 4 has this minima kind of a thing. It's not a minima, but still you can see that elbow point, which is there in the number of clusters is equal to 4. And after that, there is no minimum point that you can see at either number of clusters. So you can say that 4 would be the optimal number of clusters based on the elbow curve. So whenever you're doing a k-means clustering, never forget this step. This is the most important step. Otherwise, you would be just creating some random number of clusters, which might not be the correct way. So you only have to choose clusters which are exactly the number of clusters that you need for your data. So for example, if I have 100 rows, I don't necessarily need 10 kinds of people segmentation. It can happen only with 4, right? So what can we do next? Let us apply k-means clustering. So now it's easy. We know k is equal to 4. Okay. Then k-means is equal to k-means. Now we have to run the same code that we had done here. Now n clusters is 4. Sorry, n clusters is equal to k, and random state is 42. As I was telling you, random state always has to be the same. Otherwise, you might select completely different data set the next time. Okay, and then you have k-means dot fit x of scaled labels is equal to okay. We are done. We have to analyze the results. You can add the cluster labels to the data set. So how can we add the cluster labels? You just have to add an extra column. Clusters is equal to labels. So labels basically gives you that information. If suppose in our case, like it was P1, P2, P3, here in this case, it would just give you 0, 1, 2, 3 or something like that. It would just give a basic label. And now let us see the cluster assignment for each customer. Okay. So print data. So we don't need to do the print. Let's just do data. Customer ID and cluster. Sorry, clusters. Now if you look at it, what's running? Yeah. So you can see that this person C11100001 is in cluster number 2. C1002 is in cluster number 1. And so on, this person is in cluster number 0. So these people 101, 104, 105 must have some common characteristics due to which they have been placed in the same cluster. Right, and if you look at the total number of clusters, you will see it will be ranging from 0, 1, 2, and 3. Right? So this is the purpose of clustering, so that you can, so in an industry like a credit card industry, where just by looking at the purchase history or looking at what kind of things the person is doing, what is the credit history, you can actually identify which customer falls in which types, and then they can direct their marketing and initiatives all according to that, or prescribe a new card to a customer who is at a higher range. So this clustering is very, very necessary method which is used in the banking and financial services industry. Right. So this is a practical use case, and this is like the very basic example that I had given in the first slide, that why k-means clustering is used. So this is like a double problem that you're solving. You are also solving the unsupervised learning case, and you're also solving a customer segmentation problem. Okay. So principal component analysis is another it's another unsupervised learning algorithm, which is used to transform high dimensional data into lower dimensional space while preserving the most important information. So before going through all this, what I'll try to do is I'm trying to complete the remaining slide, And if we have time towards the end, I would again come back here on PCA. Okay, I hope that's okay. So I'll come back again in PCA. First of all, we would be going back to the slide. Yeah. So these are the various evaluation metrics in machine learning, right? So you have to see what is the accuracy, what is the precision, what is the recall, and what is the F1 score. And I've attached the formulas and everything for that as well. So towards your bottom left, you can see this square box, which is called a confusion matrix. Okay. So in confusion matrix, you have this true label and predicted label. So you can see what is the true positive. Then what is the false positive, false negative, and true negative. And then you can see the formula, what is precision. So precision measures the proportion of correctly predicted positive instances. Okay, so although this sounds similar, but accuracy and precision are not the same things, right? So precision basically is true positive divided by true positive plus false positive. Okay. Then what is accuracy? Accuracy measures the proportion of correct predictions. Accuracy is true positive plus true negative. So it's not just the positive things. It's also that I have been able to predict something negatively and that I've done correctly. So that's true positive plus true negative by everything, all the probabilities that are possible. That is your accuracy, which is a measure of correct predictions. And then the remaining two metrics which are there, they are a measure of the precision and accuracy and so on. So if you look at what recall is measures the proportion of actual positive instances correctly predicted. So that is true positive divided by true positive plus false negative. And then F1 score is a slightly complicated topic which combines precision and recall into a single metric. That is 2 multiplied by precision multiplied by recall divided by precision plus recall. Okay, so these are few evaluation metrics which are used in machine learning. Definitely you should use the cross validation process in the very beginning and then look at your accuracy from there. But if somebody asks you, okay, what is the prediction? What is the accuracy of your model? Why are you using this model? Okay, so the definition that we say that, okay, my model is producing results with 95% accuracy. That's why we should definitely be using this model in production. So how can you say that? You can say that using these measures. We'll be using a very basic example in order to look at the accuracy, precision, recall, and F1 score with the help of a code. Now I'll go to the next slide. Yeah. So what are the various challenges that you face in machine learning? Okay. Before that, let me just show you the code let me just explain you the code for this thing, evaluation metrics. Okay. So this is your true label and this is your predicted label. Okay. So if you look at this, true label is 1011, 0 is 1, 0, 0, 1, 1. So these are, for example, these are your Y or the dependent variable or the output variable prediction. Okay. This is your true label and this is what your predicted labels are. And you have to calculate accuracy, precision, recall, and F1 score. Good news is you don't really have to use all those formulae because you already have a library. You already have a library and a module for all those things. So let us look at the theory a little bit. In the confusion matrix, the rows represent the actual class labels. 4 elements are true positive. What is true positive? The number of instances that are actually positive and are correctly predicted as positive by the model, right? So this one would be a true positive, this one in the beginning, because even in the actual label, it is 1. True negative, the number of instances that are actually negative and are correctly predicted as negative by the model. So something which is 0 in both the places. So for example, this value, this is a true negative value. Then you have false positive. The number of instances that are actually negative but are incorrectly predicted as positive by the model. So something which is 0 here but marked as 1 here. So this one is a false positive. And false negative is your number of instances that are actually positive but are incorrectly predicted as negative by the model, which is 1 here and 0 here. So this value over here is a false negative. It might take a little time to actually get acclimatized to these terms. But you can maybe take a screenshot of this or look at this. So true positive, true negative, false positive, false negative. These are the various instances that we have to look forward to. Now, what are we going to do? We are going to calculate the accuracy, precision, recall, and F1 score for this particular data that we have. Okay, so how are we going to do that? So let me select the metrics from sklearn.metrics import accuracy score, comma, precision score, comma, recall score, F1 score. Okay, so everything I've got from one place itself. So it's that easy. You don't really need to do that TP by TP plus NP and all that. So what is accuracy? How can you measure what is accuracy? Accuracy is equal to accuracy score, true labels, comma, predicted labels. And it's this easy. You have to copy this entire thing and paste it below everything. Just you need to change the names. So this is not accuracy, this is precision. So this would be precision score. This would be recall score. This would be F1 score. Okay, so let us look at this. Say what is the accuracy? Let us look at that. So you can say accuracy is 50%. Okay, which basically means that, where is it? Yeah. So basically your true positive plus true negative divided by everything. So whatever is correctly predicted is 50%. Be it negative or positive, that is 50%, right? Then what is precision? Precision is 60%. Okay. So precision basically means on your top you'll just have true positive, and below that you'll have true positive plus false positive. Then you have recall. Again, recall is 50%. And your F1 score is 54%. So this is not a very good performance by the model. That's what we can see. So never even try to productionize anything below 80. Definitely don't. Okay. So this is about the evaluation metrics. Yeah. So next we have, what are the challenges that you face in machine learning, right? So some challenges that you have in machine learning is overfitting. Okay. Overfitting means that the model performs very well on the training data but fails to generalize to the new data. So for example, I've given way too many training data or training points to the model, and it is accurately following each and everything. But whenever it's getting a new data, it's failing to do so. So for example, you guys must have if you are in college, you must be having some people, right, in your college who are very well at memorizing stuff. Okay. They're very well at memorizing stuff. And if the same questions appear in the question paper, they'll score 100 out of 100. But suppose something else happens, some other teacher has set the question paper, or some bouncer comes upon the question paper, then they'll not perform well. So that is a case of overfitting, right? That you read the model very well, the model reads the training data very well, but fails to generalize new data. Okay, that is called overfitting. Underfitting means that the model is too simple and fails to capture the underlying patterns in the data. This is something that we faced with a logistic regression problem over here. So we just had 4 or 5 data points and we were expecting logistic regression to perform very well. So when it came that we want to test something on the new test data, one of the data points was not coming well, right? So that is called underfitting. Then we have data quality. Poor quality or insufficient data can lead to inaccurate results. So poor quality means you can say that a lot of values in the columns are missing values maybe. So that can be insufficient. Or you want to predict something, but you have just one column. So it can be difficult, right, to predict something just based on one attribute. So they can lead to inaccurate results. Then you have feature selection. So feature selection means identifying the most relevant features for the problem at hand can be challenging. However, it's not very difficult with feature engineering. If you don't use feature engineering, it's difficult. Then you have interpretability. Some complex models lack interpretability, making it difficult to understand the decision-making process. Let me give you practical examples of all the things that we have talked about here. Okay, so overfitting. So for example, you have a data set of housing prices with features such as square footage, number of bedrooms, and location. So if you train a machine learning model, such as a decision tree with high complexity and allow it to have too many branches and leaves. Why are we saying too many branches and leaves? Because you are using too many features, right? So the decision tree would be very large. So it would have too much features. It may memorize the training data too closely, and the model may perform very well on the training data, achieving high accuracy. However, when you use this overfitted data to predict the prices of new houses, it may fail to generalize and provide accurate predictions. So it may fail to provide accurate predictions. That's what I meant. Then you have underfitting. Continuing with the housing price data set, if you use a linear regression model with only a single feature, right? Because I was talking about y is equal to mx plus c. But y is equal to mx plus c means you're using just that one x, which means just one feature, such as square footage to predict prices. It might be too simplistic to capture the underlying patterns in the data. So pattern comes with complexities. So you have to find a very good balance between your fit. And so this is called a bias, okay, in machine learning. So this underfitted model would fail to capture the effects of other important features like the number of bedrooms or location. So hence it would have a low accuracy on both the training data and new data, as it is too simple to make accurate predictions. So never ever use linear regression if you have a lot of input variables and all the variables are important. In that case, do not use. Okay. Then you have data quality. Imagine you are building a sentiment analysis model for customer reviews and you have a data set that contains reviews with inaccurate or incomplete labels, such as missing data, bias sampling, or noisy text. So it can lead to misleading results, hampering the model's ability to learn meaningful patterns and make accurate predictions. Okay. Sorry. Next, you have feature selection. So feature selection is like you're building a spam email classifier and you have a large number of features, including the presence of certain keywords, email length, sender's address. However, all the features may not be relevant or informative. So if you give all the features in your list, what happens is it won't be able to identify which is the optimal subset of features, and it won't be able to classify things well. And maybe another mail that comes to you, you might classify it as spam, but it's not actually spam. Okay. Then lastly, you have interpretability. But this is important. So if you guys have heard about deep learning, so deep learning means that you have neural networks, suppose multi-dimensional, multi-layered neural networks, okay, which have very high accuracy in various tasks, but are often considered black boxes lacking interpretability. Because you have a lot of hidden layers. Even in neural network, they call it hidden layers, which means that you have no idea what is going on, what are the various functions that are being used. You just know what is the input and you have the output. So while it might be very useful and have accurate results, but it cannot predict or it cannot show the proof of how it is happening, making it difficult for humans to understand how it reaches its predictions. In some domains such as healthcare or finance, interpretability is crucial for regulatory compliance, understanding potential biases, or gaining trust from stakeholders. Therefore, striking a balance between model complexity and interpretability is an ongoing challenge. So these are few challenges that are there in machine learning, and you need to come up with methods how you can eliminate this. So for example, overfitting and underfitting can easily be countered by using the cross-validation techniques that we had done. You can also counter that using the suitable algorithms for each and every step. So in a data set which has too many features, you should never use linear regression. Okay. Then you have data quality. You have to make sure that all the data is not, none of the data is missing or something like that. You have to handle data very well. Then again, feature selection, you have to use feature engineering very well, and interpretability is there. So you don't have time for the spam ham classifier, but it is a little in depth about natural language processing. That's why even if we don't do it right now, maybe we can take it up in some future EdYoda workshops. So going on to the last slide for today. What are the different applications of machine learning? Okay. So definitely you have image and object recognition or image processing, right? So what exactly is image processing? So whenever you see, I'm sure you people might have learned or heard about medical image processing. How do people, doctors, know nowadays that if a person has cancer or if a person has some kidney stone? And just by looking at few images, you can understand what is the positioning of stones maybe, or what is the positioning of the cancer which has reached somewhere. So image and object recognition are used widely in medical imaging, medical sciences. It's also used in a lot of other ways, such as autonomous vehicles, but that is a combined thing. You can understand where the obstacle is, and then you can identify things that you should bend your car or whatever. So but that's a combination with autonomous vehicles. Then you have natural language processing, which is used widely to generate keywords for sentiment analysis, then for improving the customer service. If you just look at what are the customer reviews, you can improve customer service with that. Fraud detection, the same use case that we had used with credit cards, right? For k-means clustering, the same logic can be used to identify where you can use it for fraud detection. Then recommendation systems, you guys always see that whenever you open Netflix or Amazon Prime, you get what exactly you're looking for. How is it happening? Because it is working on your search history. It is trying to understand, okay, so this guy loves Leonardo DiCaprio movies, so let me suggest more of his movies to you. So that is a recommendation system. Then you have sentiment analysis. You, just by looking at a text, you know that if this is an angry tone, if this is a sad tone, if it's a happy tone, or so on. Then you have autonomous vehicles, which are basically self-driving cars. So one day you will see that you no longer have to drive cars. The cars will drive on its own. Whenever there's an obstacle, it will bend because of that image recognition or image processing which is happening there. So these are the various and variety of applications of machine learning that are there. And it's a very very nice role, and it's very such a intricate field that can continue for years and years to come. So with that, I'll close, and these are the careers in machine learning which are definitely you guys would be interested in. So things like data scientist, machine learning engineer, AI researcher, data science consultant, ML product manager, and so on. So all these are very various different career paths. However, there are a few intricate differences between all of these. So a data scientist does not need to code a lot, because he definitely needs to code, but then a machine learning engineer actually has to develop all these libraries that you can find here. What did I do? I just did a from skykit.model, for example, import this. But machine learning engineer actually has to develop all those libraries, right? And data scientist knows how to use which library where. He knows what algorithm to use or which model to use in which particular use case. Then AI researcher, since AI is a broader umbrella of things, it not just entails machine learning, it also contains deep learning, natural language processing, generative AI, and a lot of other things. So you can actually go into research and development, you can go into R&D and look into things. You can be a data science consultant, you can be a data scientist, as well as be an active contributor to the business cases. And you can also be an ML product manager once you identify what are the important product metrics which are important, like the ones that we were doing, right? We were trying to identify what are the key features. So key features, say in a product use case. So you know that you can be a good product manager if you know that which use cases you know, but you also have the knowledge of machine learning. So that's a very lucrative career, I'll say. With that, I'll like to close, and I'm open for any questions that you guys have. Yeah, so just to give you a brief recap of whatever we have done so far, we have understood what is machine learning exactly, what are the various applications of machine learning, some popular machine learning algorithms like linear logistic decision trees, support vector machines. These are supervised algorithms, which means that you're giving the model enough data to train itself, right? And then you're asking it to test on some unknown data. Then k-means clustering and PCA. These are things which are unsupervised learning algorithms. And we have given some examples of all of that. And then you have what are the key 7 steps in machine learning. So we have taken that example with the help of a decision tree classifier. What are the evaluation metrics in machine learning? Accuracy, precision, recall, F1 score, and so on. What are the challenges in machine learning and how can you counter that, and the applications of machine learning, and lastly, the careers. So I hope that today's workshop was useful to you guys. We'll try to bring more workshops similar to this in the near future. So I hope this was useful to you people. So yeah. Over to you, Rishabh.
And I hope that all of you, while doing this workshop, didn't feel like it was like so much. Because one thing, Tanusha, we have heard, like, I don't have much idea about technical, but machine learning is very difficult. One question that keeps coming up again and again. What will you tell them?
It's definitely difficult. I mean, it's not very easy. You have to master it again and again. I'll say even people with a PhD, even they say that we have not learned everything. So it's difficult, but you need to just master upon it. You need to learn more and more. So that's
okay. So it is difficult. If you are feeling it's difficult, we are all on same page, but we have to practice a little bit more, put more effort. And yeah, like now you can see Tanusha, she has got it. She's able to teach us all everything about machine learning. So even if you put the effort, you'll be able to do it. So Tanusha, like how would you suggest them if someone wants to study like machine learning, how to actually begin this?
I'll say that most people always begin with that Andrew NG course. That's a really nice course, how people get started. And after that, you need to have a very good understanding of data sets. You just need to come and experiment with data sets. Like Kaggle has a lot of these repositories, UCI, all these have a lot of repositories. You just need to download the data set, upload it, and do whatever you can with it. You have to experiment. You have to do a lot of Google search. And now with ChatGPT coming up, which algorithm suits which the most. It's just a process it's a reiterating process. So it's never ending.
Okay, great. And when did you study this?
In my second year of college, I started from then.
Okay, and when you started, how did you feel at start?
I had a lot of sleepless nights at that point of time. I was very confused that why is this happening? If this is happening, why is that happening? I mean, the mathematics is also so confusing, and it's not even about programming. It's more about the logic behind. So that was what was confusing, but it improved over time. Still a lot to learn, but yeah.
So did you learn this like on your own alone, or did you have a group of people who are studying together this thing?
I had my mentors. I did a lot of research internships and all during that time. So I had my mentors, but I did a lot of self-study as well. So
okay, great. So those are few questions. If you have any more questions, do let us know in the chat box, and we'll definitely try to answer them. And do let us know if you want us to make any other workshops, topics that you want us to make on. Do let us know in the chat box. We'll definitely try to bring workshops on those topics. And again, this was just a quick overview. If you want to see much more detailed courses like this, then do check out our website, which is www.edyoda.com, where you'll be able to find much more detailed courses. And we'll try to bring in more and more courses. So let us know in the comment section which topics do you want us to make workshops or courses on. And yes, thank you so much, Tanusha, that you came here and shared your knowledge here with all of us.
Sure, no worries.
And we'll definitely hope to see you back again on workshops. So a quick like if you enjoyed the session, and subscribe to the channel and press the bell icon so that you get notified when we keep having workshops like this. So with that, we'll be coming to the end of this session, and thank you all for watching, and take care. Bye-bye.